All right, and welcome to United Astronomy Clubs of New Jersey. Once again, we're back on Saturday night here online only since we are during the winter season. We are excited because it is just about 2 months until we're back on site at the observatory where we'll be able to accept public actually onto premises again. Uh, so don't forget to mark your calendars for that. April 6th, that will be our first in person session again. And then April 8th is actually going to be the solar eclipse, where we're going to have an event held there as well. To see the what we can see of the eclipse, we're in about the 90 to 95% totality range, so we're very much looking forward to that. So, for all of you out here who haven't joined us before, do check us out on our website, uacnj.org. That's where you're going to find a list of all our member clubs because, yes, we are a club made up of other clubs. And our volunteer observers come out and help us do our outreach and our on site public programs that we offer completely free. You can also check us out on our social media pages, our Facebook, our Instagram. We do list our events there and any fun tidbits. We do occasionally post a fun article that one of our members writes regularly. So, but we are here tonight for What's Up in the February Sky. Uh, and our speaker tonight, of course, is Lonny. Lonny has been giving the What's Up series since UACNJ opened in 1994. He received degrees from Stevens Institute of Technology in physics and computer science, then learned space art, animation, and video on his own. Lonny is the only member of the IAAA who specializes in virtual reality worlds. He wrote the first interactive space history ebook and is most pleased to have married Jan, his narrator. And with that, here's Lonny for us.
Thank you very much, Kim. This series wouldn't be possible without the diligent behind-the-scenes work by Kim, Chris, Jeff, and all the members of the UACNJ, which is the United Astronomy Clubs of New Jersey. The IAAA, by the way, is an organization to which I belong. It's the International Association of Astronomical Artists. And here we're looking at what's up in the February sky in the middle of the month. On the 15th of the month at 21 hours in the lower left, 21 minus 12 for you mathematicians out there is 9 p.m. You'll be looking due south at a famous constellation with these stars, including Betelgeuse and Rigel, and that's Orion the Hunter. I'd like to give a special welcome to any first-timers who are coming to this series, especially our friend Joe in Clifton. I'm glad you're out there watching, and I hope that all of you will join us for future episodes like what's up in the, you guessed it, March sky up next. In the February sky on the 15th, we'll see the moon, not too far from the planet Jupiter, amongst the bright winter stars, and that's what we're going to talk about tonight. But first, I'd like to wish a happy birthday to Ferdinand Magellan. This is today. He was born today, not today, but this day in 1480. And Magellan is interesting. He didn't make it all the way around the world, but while he was in the southern hemisphere, he noticed two clouds, large and small, which you could find today if you went to South America, Australia, and looked for the Southern Cross, which points roughly to where the south pole of the Earth points in space, right there, South Celestial Pole, SCP, and there are no bright stars near it, as we have our brighter star Polaris near the North Pole position. Polaris is fairly bright, it's easy to find. Sigma Octans is a fairly faint star at the limits of what the naked eye can see. You would see it in a very dark sky like this. And not far from that pole, here, the large Magellanic Cloud and the Small Magellanic Cloud. And these are not clouds at all. They used to be thought to be nebulae, astronomical for cloud, but we now know them as miniature galaxies that have passed all the way through ours and come out millions of years ago. Someday they will merge with our galaxy and come back in again. But we can see on long exposure photos trails going from our galaxy to these galaxies. Not in this picture, which was made from a free program that I'm going to tell all of you all about later that you can get and use. So those are the clouds of Magellan. I don't know if anyone in the audience has ever been to South America or South Africa or Australia, below the equator, far enough to see them. But these are stars that we will never see from New Jersey. You cannot see the Southern Cross or the Octant or the Hydra, or the reticle, a lot of obscure constellations. We're going to talk about not only events that are happening this month, which are few, but also what we can see in the night sky for this month. So this is it for February. I want to thank you all for being such a good audience. That's the end of my talk. There's not much happening in this very short month. Good night, everybody. Just kidding. I'm winking with my naked eye, which I hope all of you will use to go out. It's a nice clear night out there tonight, as it will be over the next few nights. Even though there isn't a lot to see, we're going to take a look for the new moon, the full moon at the end of the month, and in between, in the middle of the month, a conjunction. For those of you who like to jump the gun, look up the word conjunction. It has the root con in it, which means with or together. Junction, a joining together of what? Let's find out. First, the new moon. Great time to see faint stuff in the sky. If you'd like to learn a lot about the moon, I like the website Moon Giant. One word, moongiant.com. And it shows a phase. Oops, I forgot to change it to February 3rd, just past first quarter. When I made this presentation, it was in January. But you can adjust the phase of the moon to show what it is on any given day. Here are the main phases of the moon. You can print this out. You can find it, you can customize it. Last month, I pointed out that all the main phases of the moon fell on a Thursday, not so much in February. Right? But we have three of the phases on a Friday. Friday the 2nd, the last quarter moon. So half the moon is lit up, the last quarter. Why do they call it a quarter if half is lit up? Where's the other 3/4? Here's 1/4 on the left lit up. The darker side is not lit up. That's 1/2. Well, there's the half of the moon we never see, the other side, which does not have these dark markings, the mare, or seas made not of water, but frozen lava. Other side. So don't forget, there's another side of the moon we don't see. The moon all spins around on its axis the same amount of times it takes to go around the Earth, which means it always faces one face to the Earth. Synchronous rotation. That's the fancy astronomical term. I'll throw out some fancy terms tonight. Some of them might be made up. You can fact check me. I'm sure some of you have your devices ready. You ready? Good. Taking notes? Probably nobody is taking notes, right? Last quarter moon, when would you see it? If the moon is facing in the south to the left, lit up left, then the sun is coming up in the east. This would be in the morning. As the sun rises, before the sun rises, you see some of the brighter stars for the scorpion. The scorpion. Do we see the scorpion in winter? Do we see the scorpion near the hunter, Orion? Do you know the story of what the ancient gods did to protect the hunter? They put him into the sky. He was stung to death by the scorpion, but they placed the two in opposite ends of the sky so they would never meet again. Scorpion in summer sky, night, and Orion in the winter night sky. So if you get up early in the morning, you see summer stars that you would see at night, the moon. Over here, the middle of the month, the first quarter moon, you go outside 9 o'clock, 8 o'clock. Actually, I set this to 8 o'clock. The moon is facing lit up to the right where the sun is setting, near, and the moon is near the bull and the hunter. And the best time to see faint objects in the sky, nebulae, nebulas, take your pick, is which is the right pronunciation for more than one cloud nebula. Think about that. I'll tell you in a minute. Great time to see faint objects like that or star clusters. New moon is in the the daytime sky near the sun. Can't see it. And the absolute worst time to see anything except bright stars and planets, full moon, the 23rd. 24th. 2nd, 9th, 16th, 24th, all about 7 days apart, right? The moon goes around the Earth in 27 and a third days, divided by 4, roughly 7. Well, the phases of the moon don't take the same amount of time as the time for the moon to go around the Earth. The moon has to catch up because the Earth is moving around the sun. So if you go by lunar phases, it's 29 and a half days, not 27 and a third. Last quarter moon, I showed you in a small picture before. There's the last quarter moon. You want to see it? Get up at 6 in the morning. This is February 2nd, 6 in the morning. Look for the scorpion, the bright red star Antares, quarter moon. The first quarter moon, that's easier for those of us who have to go to bed early, 20 hours military time on the 16th of February. What's 20 hours? Subtract 12. Right? Most of us are still up at 8 o'clock. I have a friend who goes to bed by 9 because he has to be up at 5 in the morning. But he could still see the quarter moon due south as the sun is setting. You wouldn't yet see the stars of night until it gets a little darker and later. So every month, the full moon has a special name. Actually has more than one. And I got these names from Wikipedia. Wikipedia is a great resource to start finding information. Not all of it is accurate. I challenge you to use the references in any Wikipedia article at the end to dig deeper. By the way, is it nebula or nebulae or nebulas? More than one nebula. Well, if you said nebula, you're right. And if you said nebulae is correct. If you said nebulas, you are right. Both are correct. This is the raccoon full moon. My favorite, most poetic, the bare spots on the ground full moon. That's the longest name for any month of any full moon. And these are according to a guide used by the Boy Scouts for decades. But in the Farmer's Almanac, they refer to Native American names, and a really beautiful one is the snow moon, the February full moon known as the snow moon. Also, other names, hunger moon, storm moon. And during the month of Manga, which is sometime between January or February, on the 24th, the full moon this month, that is celebrated for the festival of Indian festival of Magha Purnima, and that is the East Indian, not the Native American Indians, just to make that perfectly clear. So a festival this month for the snow moon, what we call the snow moon. The events, again, not too much going on in February, but I do want to draw your attention to a beautiful grouping of a planet and our moon. A crescent moon, a thick crescent moon, that's the phase of the moon. Sometimes when the moon is very thin, a very thin crescent, shortly after the middle of the month, after it's new, you can see the new moon in the old moon's arms. It's a poetic say of saying a faint light on the dark side of the moon. What's making that light? Think about that. Over to the left, you're going to find the planet Jupiter. This is what it looks like in a large telescope. And on the 14th at 22 minus 12, that's 10 p.m. on the 14th, the moon Europa comes out from behind Jupiter. You'll see all four of the giant moons of Jupiter discovered 413 years ago. Oops, 1610 would be 404 years ago by Galileo. So we call these the Galilean moons. Jupiter has about 95 or 96, 95, I believe, moons. Saturn beats it with 146. New moons are discovered all the time. But you can see these moons and Jupiter even in a pair of binoculars. You will not see the disk of Jupiter like this. You see it like this in a medium-sized telescope, but we'll see what it looks like in a small telescope shortly. It's a beautiful grouping coming together, a conjunction. And in some cases, a planet will pass behind the moon. We're not going to see that. The conjunction of Jupiter and the moon happens again on the 14th. It looks about this close compared to the size of the constellations. The V makes a face. And the hunter, the famous hunter Orion, is on the left. Not too far from them, Jupiter and the crescent moon, a beautiful grouping, beautiful conjunction. And you can see, even in a pair of binoculars, you'll be able to find the moons of Jupiter. So what do we do now that we've got a little warm up? Why don't we simulate the sky with a free computer program called Stellarium? And I'll show you how to get this program later. You can download it, you can run it off their website, you can use it on any mobile device. It lets you set the sky to any location, anytime in the past, present, or future, anywhere on Earth. And right now I'm pointing north. So just as we see it here in Stellarium, what do? We go outside, we look for the cardinal point, the letter N, correct? Anyone shaking their head yes? No? And we look for some familiar patterns in the sky. 8 stars in the shape of a kind of a bowl standing on its handle. A pot, a dipper, and if we follow these pointer stars, 5 times their distance apart, in the sky we don't measure distance with miles or kilometers or inches or millimeters. We use angles. The whole sky is how many angles? How many degrees? 360, that's a lot. This is only 5, which is about the angle your fist would make if you hold your arm straight out, roughly, very roughly speaking. 5 times their distance apart would be 25 degrees. 5, 10, 15, 20, 25, right there. If you click on an object in Stellarium, it identifies if this is the star Polaris in 1, 2, 3, 4, 5, 6, 7 stars in the Little Bear, Ursa Minor, Umi, Ursa Minor. Astronomers, being as clever as they are, abbreviate the stars by how bright they are with a Greek letter, and 3 letters for the constellation. Ursa Minor, Small Bear, Small Dipper. Right? To make things a little easier, we can cheat and draw lines the way you see them on star maps. And if I look up a little bit higher and further out, I can see all of the Great Bear, Ursa Major, with the 8 stars in the Big Dipper. I said there were 7 in the Little Dipper, 1, 2, 3 in the handle, 4 in the bowl, 1, 2, 3 in the handle of the Big Dipper, 4 in the bowl. Wait a minute. If I go zoom in a little bit more, I see the Big Dipper as it would appear in the real sky, fairly large. See the 8th star right there? Famous double star. This is not a real, what do I mean by real double star? This is not a true spectroscopic double star where the stars revolve around around each other, held on by gravity, the way the Earth holds on to the moon. This is an apparent double star, where one star is closer to us, 78 light years away, and the other star 81.7 light years away. So this is an accidental alignment. If you went into space far enough, the 2 stars would not be near each other. Big Dipper. Little Dipper. Well, now you know two constellations. Large Bear, Small Bear, dragon between them is low in the sky. Might be in trees or houses where you live. Where I live, the houses get in the way to about here. If I look up higher in the sky, I can see the king. Looks like a house to me. And the queen looks like the letter M or the letter W, depending on the time of the year. We're looking at the sky as it appears right now in Stellarium. The time is here, 20 hours and 20 minutes and 33 seconds. So that's 20 minus 12 is 8 p.m., 8:20 p.m., the time right now. And that's exactly the way the sky looks. So you've just learned 5 constellations of the official number decided upon by the International Astronomical Union, the same number as keys on a piano. I'll let you figure that out. So if you have a piano, go right now, go run to the piano, count the keys. I'll wait. Go ahead. All right, I won't wait. We don't all have time to wait for that. You can find out how many constellations there are. You can count them, or you can look it up. Use Wikipedia. I like to start in the north because once I'm oriented, I can use a technique called star hopping to hop from one group of stars to another. We're looking at the sky here flattened out onto a flat map, much as a planisphere does it. If you go visit our gift shop at the United Astronomy Clubs in Hope, or to a science museum or a planetarium gift shop, you will see a planisphere like this, a round circular chart that you can set to any day or time of year. Right now, we set it to now. But the advantage of a computer program is you can remove the distortion doing that by mapping things onto a small flat plane just by zooming in. We can zoom way in and see things close up. Hiding in the trees is this huge square that I talked about in What's Up in the springtime months. Big square. What do we call this great square? You guessed it, the Great Square of Pegasus, the flying horse, with the Princess Andromeda riding the horse in the back, with the Andromeda Galaxy, nearest galaxy to large galaxy to ours. The nearest ones are the Magellanic Clouds and a few other small miniature galaxies. What would our galaxy and the Magellanic Clouds look like from outside if we could travel 2.5 million light years? If you want to figure that in miles, multiply 2.5 million times 6 trillion. 12 million trillion. It starts to get fairly meaningless when you use miles. The Andromeda Galaxy kind of looks like our Milky Way, a little bit tipped, edge on. It's very flat. It's got 2 big satellites and a bunch of other small ones we can't see. Just like our galaxy. Reddish on the inside, bluer, bright blue stars light up the gas. Dark lanes of dust. A small telescope looks kind of like that, or a pair of binoculars. It's the farthest thing that your naked eye can see in the universe. It's in the Guinness Book of World Records. But we talked about that last time. The Milky Way is still rising above and over the sky, but we're going to turn our attention past the west where the stars of spring are disappearing. We talked about Triangulum and Aries in the past. What we're looking at now in the southwest is the bright planet Jupiter, not far from a beautiful star cluster. In the real sky, this thing is fairly large. I got a lot of text in the way, and I can turn some of this stuff off. Deep sky objects. Well, that didn't work. How's that? That's what the Pleiades look like, the 7 sisters. With my older eyes, I see 6. 1, 2, 3, 4, 5, 6. Some of you might see 7 or 8. In a pair of binoculars, you'll see more. In a telescope, dozens. This is a young cluster, an open cluster of stars spread out. Some stars close together are in globes. You'll never guess what they call that. Go ahead. Wild guess. Globe cluster is close. Globular cluster. This one's an open cluster. And a new discovery is that they think instead of these stars being born from this gas that we see reflected by the blue, hot, young blue starlight, these are very young stars. They were born yesterday, about a few 100 million years ago. The sun was born 5,000 million years ago, 5 billion years ago. They think that maybe the cluster is moving through this gas cloud and lighting it up. It's kind of an accident. Seven Sisters, beautiful star cluster not far from Jupiter. And is Jupiter a star? Let's zoom in. With a powerful enough telescope, around 20, 30, 40, 50 power, you might just start to see a flattened disk. Jupiter rotates so fast in about 9.5 hours or so. Oh, wait, that's Saturn. Jupiter takes a little bit longer. It's flattened at the poles. It's squashed. It's an oblate spheroid, squashed sphere, spinning so fast it bulges at the equator. You can see all four moons right now. If you run outside, oh, wait, go ahead. Run outside, you'll see Io, and Europa, and Ganymede, and Callisto, which just happens to be, by sheerest coincidence, the order in distance of these moons from Jupiter. Closest is Io, then Europa, then Ganymede and Callisto. Ganymede's so large that it is the size of the planet Mercury. It's the biggest moon in the solar system. And it is covered with ice. It has water inside, and there may even be life inside Ganymede. But even more fascinating is the moon Europa, which is an even better candidate for life. The smallest but brightest of all four of the Galileans. How could it be the brightest and yet the smallest? Smaller than our moon. Wait, that could be wrong. Yes, it is. Actually, I think you'll find the diameter 3121 kilometers. The moon is 2,160 miles times 1.6. Quick, mathematicians in the audience. That's more than Europa. Europa has a deep ocean. It's been kept from freezing for billions of years by Jupiter pulling on the moon and creating tides, powerful tides that crack the ice on the surface. And so we've seen geysers coming up through the cracks. We've had probes fly through them. We're sending a new one to go through and see if any life is coming out, and a lander to land by some of the thinner areas. We may find out within the next 20 years if if advanced life evolved somewhere else in our solar system other than Earth. We live in a very exciting time. You can see that moon in a pair of binoculars. You won't see it like that. It'll look like a star, but it's exciting to know what we're looking at. In bigger telescopes like the ones that amateur astronomers use at UACNJ, you can look through them. Please don't kick the telescope. You'll see details on the disk of Jupiter. If you don't have a clock drive on your telescope, Jupiter will drift through your eyepiece. Why? What's moving? Well, the planets move around the sun, but faster motion yet is the Earth rotating on its axis makes things seem to move from east to west and set in the west, and that's what Jupiter's doing here. I can freeze the motion in Stellarium like that, and let's see what Jupiter looks like in close-up. Lots of details. See the flattening? Kind of an oval. These bands of clouds are as wide as the entire planet Earth. The whole Earth, 8,000 miles across. Jupiter is about 11 Earths across. Saturn is 9. Uranus and Neptune about 5. These are big planets, so scientists have given them a very scientific name, gas giants. Gas giant planets. Those four, plus the inner four rocky planets, Mercury, Venus, Earth, Mars, make up the major planets of the solar system. And look how far out I have to zoom. Note the field of view here on the lower left. If I were to look at it with, let's say, 1 degree, half a degree. It's about the size of the full moon. Like that. Looks pretty small, doesn't it? The human eye can see about 180 degrees roughly, but our more detailed area, 40 or 45 degrees. So if I zoom out to give you a view that's about 42 degrees, Jupiter looks like a star. The way you tell it from the other stars, how can you tell? You can. It's not only bright, but it won't twinkle unless it's extremely low in the sky. Stars twinkle, they're so far away, they activate only one little cell in your eye, but Jupiter activates more than one. That's a planet. It can be found amongst the stars of Cetus, the whale, or the sea monster. Take your pick. Nearby, Pisces, the fishes, are setting. Jupiter passes through certain constellations called the signs of the zodiac. And we can actually draw that out because it's the path the Earth takes around the sun, the orbit of Earth around the sun. If you draw it out into space, it will cross through Cetus, well, near Cetus, Aries, Taurus, Gemini. Have you heard these names before? Cancer, Gemini, Taurus, Aries. If we were to mark the path that the Earth orbits around the sun, and that's called the ecliptic. Anybody see it today? Right? So you go outside and you look for an orange line passing. No, not going to see that. You need to memorize the signs of the zodiac. All 13. Yep, 13, not 12 anymore. The Earth has shifted on its axis since astrology began, and now the sun, moon, and planets pass through 13 signs. Past Jupiter, past Taurus, the Gemini, the Cancer, the, should we cheat? Taurus, the bull, Gemini, twins, Cancer, the crab, Orion, the hunter. Orion helps us find things in the sky using that technique I mentioned before, star hopping. If you go outside, you're not familiar with the sky, you're not going to see the ecliptic path, the orbit of Earth. You're not going to see lines, but you can line up Orion's belt and follow it in a straight line right through the Hyades star cluster, an old open star cluster older than the Pleiades. So along Orion's belt, hop past the Hyades to the Pleiades, seven sisters. Or you could go the other way, down to the second brightest star in the sky, Sirius. You see the head, body, feet, tail? No? How about now? What is it? Canis, Major, Alpha, brightest star in Canis, dog, Major, large, the dog large. Is there a dog small? Alpha, Canis Minor, Procyon. By the way, you can refer to stars by their numbered names, catalog names, but the most popular way to do it is either by the Greek letter and the constellation or the Arabic name. The ancient Arabic astronomers kept astronomy alive through large parts of the Dark Ages about 1,000 years ago, and we still use a lot of those names like Procyon, Betelgeuse. What is Betelgeuse? It's a giant red star, huge red star, fairly bright. It marks, well, when I was a kid, they told me it was his shoulder, but literally translated, Betelgeuse, it can be pronounced several different ways, is the armpit of the giant. Armpit of the giant. And there's his foot or knee, depending on how you draw it, Rigel. Look at the color difference, bluish, reddish. In the real sky, this is more obvious to the naked eye, kind of a slight bluish tint. It's kind of an orangey, a reddishy, orangey tint. Some stars are cooler than others. Betelgeuse is cooler than Rigel. And the sun, a yellow star, is in between in temperature. Monoceros. Mono. What's mono mean? One. Ceros, like rhinoceros. Rhino, ceros. Nose, horn. A rhinoceros is a nose horn. Monoceros is a one horn, the one horned unicorn. So we just used a technique called star hopping to go either west to the right or east to the left to find other constellations. There are minor constellations that we don't remember too easily unless we have a star map. You can get one from Sky and Telescope magazine, Astronomy magazine, space.com, lots of resources online. But this one is one of my favorites. Can you guess what it might be? You probably saw the picture. Do you remember? Ears. We can also redraw the constellations by different cultures. In his book, The Stars, A New Way to See Them, H.A. Rey redraws the constellations so they look a little bit more like what they're supposed to. He didn't do much to Gemini, but he changed Taurus quite a bit. Put the legs over here. The horns are still there. And there's Lepus. What's Lepus? No picture. Got to use your imagination. Other sky cultures, we can come back to this later if anyone wants to see Norse culture or Inuit or Native American, Egyptian, all sorts. There's a lot of things you can do in Stellarium. I'm going to set this back to modern Sky and Telescope magazine. It's pretty standard. It's based on, well, that didn't work. It's based on Greek legends, Greek mythology. Wow, that's interesting. About IAU. It looks like it's stuck. All right, fine. Good enough, close enough. Are there other things to see in the sky? Well, I didn't talk about higher. If we were to raise our heads higher, if we raise our heads very high, we could find the Big Dipper again and crane our heads backwards. But I'm going to look in this area near Gemini. You see some fuzzy clouds right there. See that? We have star clusters, nebulae, beautiful objects that you can find, or you can ask the astronomers at UACNJ in Hope to show you some of these features, to show you a colorful hydrogen emission nebula, hydrogen gas glowing in its own color, or other nebulae that just reflect light. Auriga has a lot of nebulas or nebulae. Both pronunciations are correct. And in fact, let us check out some of these just for fun. Flaming Star. Some of them have very poetic names. The Flaming Star Nebula. There are tadpoles in this one. Recognize them? Blown back by winds from stars, the stellar wind. Not air, but ionized particles, charged particles with a lot of energy. These are pictures that people pasted into an imaginary sphere to make stellarium. So one person asked me, why are the edges square? That's a limitation of the photograph. Do we still say photograph? It's not film anymore. One of the most famous of the nebulae is one that you can easily see hanging from Orion's belt. I'm going to turn off the markings temporarily, make it a little bit easier. Even in a pair of binoculars, you can sense some nebulosity here. It's not as colorful as it looks in long exposure photos because the human eye does not see color well at low light levels, but beautiful, beautiful shades and details in photographs made through telescopes. This is the famous Orion Nebula, M42 in the Messier catalog. Why is it different colors? Hydrogen gas glows red, right? So why does it look blue here? Again, the stars that are forming here are very young. And so their bluish starlight reflects off of the gas, and it's called a reflection nebula. It's really the same thing. It's a gas. And then this dark stuff, what's that? Are we looking through to space? No, we're seeing the light of the gas blocked by dust. And someday this dust will collapse around a star, perhaps to form planets. We can see planets forming now, extrasolar planets, the ones that are beyond our solar system. For the first time, we can watch them form. We can see that some of them form similarly to the ones in our solar system, but other solar systems are very different, with giant planets close to their stars, not far away, as in our solar system. One of my favorite nebulae, and I'll stop there unless you have requests for specific ones, looks like an animal. It's an absorption nebula. It's the light of the dust is absorbing the light of the hydrogen gas behind it. And it kind of looks, if you turn your head to the right, clockwise, sideways, you might see an animal here. Somebody told me a different animal from the name of the nebula a few days ago when I gave this presentation, or one that was like it. They said, I think they said a dog, but this is called the Horsehead Nebula. There again, it's drifting, right? Drifting because the Earth is rotating once around every day. You can pick up that motion in a telescope. Well, I see that we are running out of time. We want to leave some time for questions. And so a sneak peek over where we're looking in the south in the middle of the month, or actually tonight on the 3rd of February. If I look over to the east, I'm going to see the stars of spring coming. When winter is over, we'll look for the main sign of spring, M-A-I-N, also M-A-N-E. And that's a zodiac sign. The planet's going to go right through Gemini later on. It takes a long time to go around, about 12 years, 11 to 12, just under 12 years. It's going to go through Cancer and through the Lion. Anyone know what the lion's called? Just shout it out. I can't hear you, so I'll just pretend I heard you. That's correct. Leo the lion. Looks like a backwards question mark and a triangle in the back. So we've gone from north to west to south to east. And I can do a quick recap. If you got disoriented, start in the north to orient yourselves, find the Big and Little Dipper, turn around, face south, and look to the west before things disappear. The fishes are going, Aries the ram, Triangulum the... Anyone? Triangulum? The triangle, right? Brilliant. Boy, those scientists, brilliant names. Perseus, the hero of legend. The Seven Sisters, the Pleiades, and Jupiter. If you miss anything, if the sky is clear, you just want to look at one thing tonight, see if you can find Jupiter. It's very bright, kind of like an airplane. Doesn't move like an airplane, just hangs there. Bright star Aldebaran is the eye of Taurus the bull, and it makes part of what's called the winter hexagon of 6 bright stars. Can you find them? 1, 2, 3, 4, 5, 6. Rigel. I'm going to discount Betelgeuse. So start on the outside first. Rigel, Aldebaran, eye of the bull, Capella in Auriga, the chariot rider, Castor and Pollux. Pollux is kind of the color that our sun would have, seen from deep space. And finally, Procyon, the little dog star. Rigel, Aldebaran, Capella, Starlink. Anybody ever see any of those? Satellites moving very quickly. And finally, Procyon, the winter hexagon. Maybe easier if this is your first time looking in the sky. See if you can look for Orion's armpit, Betelgeuse, for the winter triangle. Just like we have a summer triangle, winter triangle. Betelgeuse, Procyon, Sirius. I said Sirius is the second brightest star in the entire sky. What's the brightest? Yes, this is a trick question. I'm going to take a drink of water while you think about the answer. That was a trick question. The closest star to us is not 8.6 light years away. It's 8.3 light minutes away, and that's our sun. The sun is a star, not as bright as Sirius. And finally, looking up, looking in the south part of the sky, you can go right along Orion's belt to find other constellations like the Bull or the Open Cluster, Seven Sisters. You can go down to find the Dog. You can look up from Rigel to Betelgeuse to find the twins, Gemini. And the rider of the chariot looks just like a chariot rider, right? I see some of you vigorously shaking your heads. I have a picture that isn't working, so you're just going to have to use your imaginations. I'm going to conclude by, ending with some news. Some amateur astronomers saw, they actually called out an asteroid colliding with the Earth. They found it 3 hours after it was found in the sky. It was found on the ground. It's a new record. A NASA system called Scout predicted the impact time and the site within a second and within 100 meters, about the size of a football field. And it landed there in Germany. This was on January 21st. And there is one of the discoverers, David Gottlieb, sorry about my pronunciation, pointing to one of the fragments. Cool. You might someday find a meteorite. If you like to get started in astronomy, binoculars are a fairly inexpensive way to begin. 7x50s are not good for older people because it wastes some of the light. The size of the pupil of your eye determines how much light gets in. If you want to find the cone of light, the size of the cone of light coming out of a pair of binoculars, divide the diameter of the lens in millimeters, the second number, so 7x50 is the second number is 50, divided by the first, the power or magnification, 7 times bigger. 50 divided by 7, anyone, shout it out. Can't hear you. 7 is close enough. 7 millimeters, my eye opens to 5. If you're over 30, the age of 30, your eye probably doesn't open to 7 millimeters anymore. I'm very jealous of you young people in the audience, especially my friend Joe. You probably have a 7 millimeter pupil, darn you. I'm jealous. But you know what? Don't get 7x50 binoculars. You can use 7x35 bird watching binoculars. But 35 millimeters is smaller lenses. These are giant binoculars. They used to be very, very expensive. They've come down in price. I'm very impressed. Check them out yourself. I just went on Amazon. But what happens if you get bored? What happens if you're not looking at the sky with your binoculars anymore and you spent all the money? Now what? You can look at birds. You can spy on your neighbors. I don't recommend that. You can use binoculars for other things, for sporting events. Bird watching is great. Bug watching, whatever. If you're interested in beginning with a telescope, the prices come way down on those. When I was growing up, when I was as young as some of the people in the audience in the time of the dinosaurs, I was that young. Telescopes cost $200 and up. Now you can get a Celestron First Scope for $72 or $80, something like that. Simple mount, easy to work, and they have a nice size to the mirror, like up to 3 inches, 3.5, some of them. There are other more sophisticated mounts. Check out, Celestron's just one brand, Meade is another. Check out space.com to discover what Dobsonian telescopes are. And this is if you're interested in more light grasp to see faint objects like nebulae or nebulas. So they cost more, 8-inch, a 5-inch aperture, that's pretty nice. It's pretty good. That's if you're interested in light grasp. And again, the mount is very simple. You do have to keep pushing it to keep up with the Earth's rotation. It's a little more expensive to get a mount with a drive that follows the sky. And now a lot of those go by computer, and the computer does the work for you. All you need is batteries or to plug it in. So that's to give you an idea of what some of those are like. The most expensive are catadioptric design. This is a uh, Celestron and MEDAR, very popular models. That uses a design called Cassegrain. There's a mirror in the back with a very short focus, so it's more expensive to figure the mirror, the shorter the focus, focal length. In front is a special corrector plate to correct for distortions. And so you've got more optics, and the more optics you buy, the more expensive it's going to be. But I have to say, in $1970 when I first priced these, it was over 2,000. So this is very reasonable if you're more of an enthusiast and want to upgrade. Let's all start simple with the naked eye. There are things that are 100% free, and those are references. There'll be a test on this, so pay attention. UACNAGE.org. Repeat after me. UACNAGE. United Astronomy Clubs in New Jersey, umbrella organization of planetaria astronomy clubs in New Jersey, and some of our neighbors, Pennsylvania and New York. Check it out. We have all sorts of events and references and all about our observatories. One of them is the Lonny Buinis Observatory. I have no idea where that came from. There are magazines still in print, Sky and Telescope and Astronomy. They have websites with subscriptions, but a large part of those sites are absolutely free. And if you forget everything else I've said tonight, even Jupiter, try to remember space.com. It's easy. Lots of good reference, news, search for life, and science. Lots of good stuff there, space.com. I mentioned earlier that the program I was using is Stellarium. The latest version is not 23. It already went to 24. I have to keep up. It started with 0.7 when I was using it. It got up to 0.14, and then they decided, this is crazy. Why don't we just call it 23? Where's the logic? Their free version, well, they're all free. You can download it for free, install it on your laptop or desktop if you still have one. You can go to this site, stellarium-web.org, and let them run it on their supercomputers. You can use it on your mobile devices, your phone with your fingers, a tablet. Very cool. And if you want to fly into space, which Stellarium doesn't do, you can do that with Celestia, celestiaproject.space, but just go and Google Celestia space. And that lets you fly to the other planets and see what Saturn looks like from some of its moons. Did you know there's only 2 places in the solar system where you can see the rings of Saturn open? They're going to close up this year and disappear because they're so thin. They're only about 30 feet thick. 170,000 miles wide, 30 feet thick. Unbelievable. They will disappear and then they'll come back. Because as the Earth goes around the sun and as Saturn goes around the sun, we see Saturn tipped at different angles. The other place, besides the moon Iapetus, which is tipped in its orbit around Saturn, where else can we see the rings of Saturn open? That's a trick question. So a quick review while you're thinking about the answer. Not much happening this month. Don't miss the conjunction February 14th, Jupiter and the moon. New moon, great time to see faint objects early in the month. Start now. You can't practice too much. There's no such thing as well, there probably is such a thing as too much practice, but practice, 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 practice makes perfect. And the end of the month, absolutely terrible time to see faint objects, but you could observe the planet Jupiter. You could look at brighter stars, double stars. Get some help. Visit UICNJ in April through October when we're open, live and in person. You'll see me there first Saturdays of the month. The full moon. Is the full moon a good time to observe the moon? Would you see craters like this? Nope. The light's right behind you. You try shining a light into the eyes of your cat. Don't make it too bright, or your dog. You see the light reflected right back at you, and that's what the moon does. No details, no shadows. You can reach me here. Astronomyinmotion.com has free 3D planets you can play with your fingers, with a joystick, with a mouse. And Mars at Your Fingertips is my latest virtual reality model of Mars. There are free ones at Astronomy in Motion. You can buy the full 4K version of Mars at Your Fingertips. There's a free demo in HD at that website. And with that, I invite you to contact me. I'll try to answer your questions. I've been a very good audience to put up with my monologue and my bloviating, as Carl Rico calls it. Carl Rico, another wonderful speaker, one of many at UACNJ, where you can find us here, everywhere. Thank you very much.
All right. Thank you, Lonnie, for another great presentation. Okay, so since we don't have in person, I don't need to give the safety briefing that I nearly started out of habit. So we're going to hop right into the questions. And the first is actually a statement. February 14th is very busy. It's a couple holidays, at least one secular one, at least one religious one, and the conjunction. I because Valentine's Day. Then it would be nice if February would finally live up to the snow moon name. It's been a while.
Yeah. Oh, and also there is a nebula in the sky called the Heart and Soul, two nebulae. So see if you can look those up for Valentine's Day.
And for anyone proposing, the Ring Nebula is also a good option. All right. So our first question, actually, your wife had answered in chat, but I'll ask to you anyway. Is Lonnie going to be at UAC&J for the eclipse?
Oh, yeah. I have to apologize. I'm usually every year, I've been doing this since we opened, the first Saturday of each month. But my wife and I and dog will be away for the first Saturday of April. So I apologize in advance. However, there will be a gifted speaker for your entertainment live.
All right. So our next question: if some stars of several constellations went missing, like just straight up for whatever reason, ceased to exist, would they have to start looking at redoing the constellations?
Ooh, that's a great, nobody's ever asked that. That's very interesting. The IAU, International Astronomical Union, in 1930 set permanent boundaries along what corresponds to latitude and longitude on Earth. In the sky, it's called declination, up, down, and right ascension in time as the Earth rotates. So they've drawn boundary lines for the constellations. And so even if a star disappeared, the stars within that region will still be called the stars that belong to Cetus or Ursa Major or Cassiopeia. That won't change. The shape will change, and so star maps will have to change. They'll have to eliminate any lines that are drawn to that bright star. If the star disappears, let's say the star is 1,600 light years away, like one of the stars in the belt of Orion, how long would it be before we knew that it disappeared? 1,600 years, right? So if something disappeared today, the light started out or stopped coming to us 1,600 years ago. A few years ago, a couple years back, Betelgeuse dimmed because of some debris that came in front of the star. It's not a very stable star. It may blow up at some point. We don't know when. But that event happened hundreds of years ago. We just found out about it in 2021, 2021, I think, is when it might have happened, or 22. Betelgeuse is pretty much back to normal. We just don't know when it'll blow up. But don't worry, it's far away.
Yeah, a bit far for being overly worried about stuff at this point. So, our next question is: how much rotational speed would a planet need to gain to become pancake shaped?
Ooh, science fiction author Hal Clement wrote a science fiction novel based on accurate science called A Mission of Gravity, in which the astronauts from Earth travel to a planet spinning so fast that the gravity at the equator is 3 times what's on Earth. So they can barely stand with help from exoskeletons. And as you go to the pole, it goes up to hundreds of times, so the astronauts couldn't go there. And the creatures who evolved are flat. They're flat creatures that look like trilobites. So when an astronaut picks up one of the creatures, suddenly they feel like they're in a skyscraper and they panic, because a fall is deadly. To spin fast enough to pancake a planet, you keep in mind that rocks have a certain tensile strength and things will fall apart if it's moving around too quickly. So there's got to be a limit to how flattened the planet could get. A rocky planet could be flattened more than Jupiter, which is gas, because it holds together stronger. Gas is more flexible. But I don't know the answer as to where it would break. To make it look like a pancake, I'll have to do the calculation and let you know next month.
And it would probably also depend on the size and already existing shape and speed. So
Right.
let's see. Our next comment was that Commando here in chat learned Beetlejuice as the armpit growing up. And I, of
Oh,
course, being the amateur I am, often refer to stars as that shiny one over there and watch as more informed people squirm.
mm-hmm. The
Be-
shiny one. Just point. It's a lot easier to point nowadays. Some of our members have laser pointers. And if the sky has the tiniest bit of moisture in it, you can see the beam.
Luckily, in Jersey, usually there's a little bit of moisture, but not overly much moisture. Uh, Unlike Florida, Florida has a lot of moisture. All right, so our next question: do different cultures use similar groupings of stars for their constellations?
That's fascinating. I actually played with this the last time I gave a talk. Would you like to take a look while we're on it? We can choose. Yeah, the quick answer is yeah, sort of, but the shapes remain the same, but the interpretation is very different. For instance, why don't we, oops, sorry, sky culture. Why don't we take a look at one of the ones that was very different? Try to remember, might have been Norse. Oh no, there's not many. No. Um, Inuit. Let's try Inuit. Uh-oh, this might, you know what? I think it's not working too well. Oh, wait. Oh yeah, let's get the names. Collarbones. Wow. The collarbones. What is that? Do you recognize the constellation? There's Jupiter. Here's Leo. The Big Dipper becomes the caribou. Ooh. Trying to figure out what the collarbones are. What am I looking at? So you see, I don't do so well without the lines either. The
Well,
dogs.
the dogs would be
Do you recognize?
Taurus,
Yeah, very good. And recognize that, everybody? The runners, the two placed far apart.
so that would be
This is
Orion.
Orion. Yeah. And the breastbone, the seven sisters. Wow, this is very poetic. Want to try? Oh, the planet Uranus happens to be close to Jupiter lately. What does that look like? Uranus. Let's zoom in, take a look. How far do I have to zoom in? What would it look like in a small telescope? I want to tell everybody the scientific word is
A tiny blue
disappointing.
dot.
Yeah. I saw it in my little 60 millimeter refractor, and it looked like a blue dot. I saw it was round, but that's all I could tell. It's a difficult object. It's
It's
tipped over
very
on its
far
side.
away, too.
Yeah, you're looking at the pole, the equator. In the past, people reported white clouds at the equator. They did not see the rings. That was discovered in modern times. Yeah, so other cultures. Let's zoom way out and let's try.
So,
Anybody have a favorite from the audience?
Yeah,
Maori,
if anyone has a
Mayan.
favorite, do put that up in chat. If you have any more questions, I do ask that you get those in chat while we're kind of exploring whether the different cultures use the same grouping for their constellations. So, which one are
Oh,
we
the
looking at
Navajo.
now?
This is Navajo. This is fascinating. Look at this. The revolving female and the revolving slim one going around, let's see, the lizard. Oh, yeah, and the revolving male. What are they revolving around? Alpha Ursa
Polaris?
Minor, Polaris, right, right. So that's fascinating. They saw a man and a woman, a lizard, and further over, the slim one, Orion. They just ignored one of the brighter stars became an arm. So they didn't make a body out of this. Fascinating. Wonder what they would have thought of the Hyades, the bull. Anything else? Nope. So while we're waiting for questions, maybe someone can ask to see any of these other cultures.
Let's go with I think there was Chinese in there or Japanese
Medieval or Chinese or oh,
because
Chinese.
they're kind of sep- a different culture, definitely much different than a Western culture that we're used to.
Right, they don't seem to have pictures. Bow and arrow. Instead of the dog star, this becomes the wild cockerel and the bow and arrow. Wow.
Well, they do have a couple dogs in
Huh.
there. I saw the celestial dog somewhere.
The toilet? Hmm. Stomach? Oh, this is very, very strange. Let's see. Try medieval Chinese. 3 stars. Bow and arrows drawn differently. Celestial dog, yeah. Outer kitchen. Egyptian. Wow. Very different. I invite you all to try this out. Try it at home. The
Hey,
bird.
I, I I do appreciate how the Egyptian and the Navajo ones are actually, when you draw the lines, you're like, ah, yes, I see what they were going for.
Mm-hmm.
Whereas the ones we have, you're like, are we sure that's a crab?
Lion. Oh, the Egyptians thought this was a lion also.
That
Interesting.
might be
So,
why we have Leo.
yeah, there's some universality going on between cultures. Interesting. Well, I've never done this before in a presentation. This is fun.
All right. Well, it looks. I'm just going to give everyone a last couple minutes to get any last minute questions, or if there was something specific you guys wanted to look at, do get that in chat. I want to thank everyone for joining us here online. I want to thank you, Lonnie, for another great presentation. Welcome to our new viewers who have joined us today. Like Lonnie has mentioned, and I've put in chat a couple times, do check us out on our website, uacnj.org. You're going to find a list of all our member clubs. If you live in the Jersey area, you'll be able to hopefully we can get you in touch with your local astronomy club because there's no better way to learn than someone who's more accessible to you. Um, you can also check us out on our social media pages, our Facebook, our Instagram. We have our Discord channel, so if you want to share any of your astrophotography pics or you have questions about your equipment, feel free to drop those comments. And as always, we do live stream these to YouTube and Twitch. So if you don't catch us live, you can always go on to the YouTube and we keep our programs archived, our live programs archived there. So if it says live program and you happen to miss it and you have a question on it, do drop your question in those comments. I do review the comments periodically to make sure that I have not missed anyone as far as questions. Um, with that, it looks like we are done with questions. Thank you all. Don't forget to hit those like and subscribe buttons. It always helps us out greatly to know that uh, people like seeing our content and want to spread the word of astronomy and science to other people. So, not a problem. It's no problem you're late. It's better you get here at some point than not at all. And with that, everyone have a good night.
Thank you, Kim, Chris, and Jeff.